Rewrite the function f of x equals 2x squared minus 12x minus 20 in vertex form by completing the square. In this lesson, you will apply your skills used to complete the square to derive a new form of a quadratic function called vertex form. Let's start with some review of completing the square. So given a quadratic equation, if you're asked to solve it, we can complete the square by getting it into the form x squared plus bx equals c. So right away I see I need to add 3 to both sides to get the constant on the other side. This leaves me with x squared plus 8x equals 20. Notice I've left a space there. That's because I want to complete the square of this binomial. So to complete the square of x squared plus 8x, I focus on the b value. I have 8. So what I do with 8 is I cut it in half. That gives me 4, and then I square the result, and that gives me 16. 16 is what I will now add to both sides. Using the addition property of equality, as long as you're adding the same value to both sides of an equation, you're resulting in an equivalent equation. Well, now on the left side, I have a perfect square trinomial. I can factor that perfect square trinomial by cutting b in half again. I know that's 4, and that's going to give me x plus 4 squared. In that same step, I've also added the 20 and the 16 to get 36. We're going to stop here because this is all we need to review in order to get an equation in vertex form. So moving on to the core lesson. What is vertex form? The vertex form of a quadratic function is y equals a times x minus b squared plus c. First of all, it's important to note that the values of a, b, and c are not the same as the values in y equals ax squared plus bx plus c. Secondly, I know you're probably wondering if you need to memorize this new form, but it's not about memorizing, it's about converting any quadratic function from standard form into this new form, and we can easily do so by completing the square. Here are some examples. The benefit of using vertex form is so that we can easily find the vertex of the parabola. When using standard form, we can only determine the y-intercept. Everything else requires calculations. So, being that both of these examples are written in vertex form, we can easily find the vertex of each. Let's start with the first one. Y equals x minus 2 squared plus 3. To find the vertex, I'm going to first focus on the x value of the vertex. So I'll look at my x minus 2, just the binomial. The x value of the vertex is the x value that will make this binomial equal to 0. So, mentally, we could do x minus 2 equals 0, and I know that x will have to be 2. So once x is 2, then 2 minus 2 is 0. 0 squared is still 0, which leaves us with y equals 3. Therefore, the vertex of this first function is 2, 3. Moving on to the second example, again, if I want to find the vertex, once a function is in vertex form, I focus on the binomial, and I see x plus 4. So I think, what can I put in for x to make that binomial equal to 0? Again, you could do it mentally, or you could just think it's the opposite of whatever's there. So I see a positive 4 there, which means my x value of my vertex has to be negative 4. And once x is negative 4, what's left is that f of x is equal to negative 5. So the vertex is negative 4, negative 5. So the great thing about this vertex form is that the vertex of the parabola is always going to be b, comma, c. Let's begin the guided practice. Rewrite the function f of x equals x squared minus 4x minus 21 in vertex form by completing the square. The first thing I notice about this function is that a is equal to 1. This function right now is in standard form, and we want to rewrite it in vertex form. Being that a is equal to 1, that makes our lives a little easier, and we can just begin by completing the square. So I'm rewriting the function, and normally to complete the square, we would move the c term to the other side of the equation. But since this is a function, there is no constant on the other side to add 21 to, so we'll just keep it on this side and just move it over. This is going to slightly change our method of completing the square, but it won't be too bad. So to begin, I'm actually going to separate, leave some space in between the x term and the constant, because I still want to complete the square of the binomial. So to complete the square, I focus on b, which is -4, divide it by 2, that gives me -2. When I square that, I get a +4. Now again, normally I would take this 4 and add it to both sides of the equation, but we have a function, and on the other side is just an f of x. So I don't want to add 4 to f of x, just like I didn't want to add 21 to f of x. So I'll add 4 to the side, but instead of adding 4 to the other side, what I can do is subtract 4 from the same side. Interesting. Because if you add and subtract the same number on one side of an equation, you will not change the equation at all. It's like you're adding 0. So now we have a perfect square trinomial that we can factor as a binomial squared, and that's going to give us x minus 2 squared. And then I also have this -21 minus 4, and that'll give me -25. And voila, we have vertex form. Since this function is now in vertex form, we can easily find the vertex. Thinking back, we need the x value to make that binomial equal to 0. That's going to be x is 2. And then the y value is the constant at the end, -25. So the vertex is 2, -25. Let's try another practice. Rewrite the function f of x equals -3x squared plus 24x minus 27 in vertex form by completing the square. So the first thing I notice here is that a is not equal to 1. So again, this is going to slightly change the way that we go about this. First step is to factor out the GCF. Fortunately, that -3 is the greatest common factor. So when we factor it out, we're dividing each of the 3 terms by -3, resulting in x squared minus 8x plus 9. We'll worry about that factor, that GCF, in just a little bit. Next, we will complete the square. So we're leaving spaces after the binomial and after the constant this time. So to complete the square, we have -8. Cut that in half, that gives us -4. Square that, and we have a +16. So at this point, we're going to add 16 and subtract 16 on the same side. Now it's time to factor the perfect square trinomial. So just this part needs to be factored. And we factor it as a binomial squared. That binomial is going to be x minus 4 squared. We can also combine the 9 and the -16 as -7, and this whole thing now gets multiplied by that -3. Well, now we need to redistribute that GCF to each term. So this isn't so bad because there's really only 2 terms inside this purple set of parentheses that we need to distribute the -3 to. When we distribute -3 to the x minus 4 squared, it's simply -3 times x minus 4 squared. And then when we distribute the -3 to the -7, it's +21. Now this is in vertex form, only this time there is an a value of -3. It doesn't affect our vertex though. So the vertex is still going to be what x value will make that binomial 0, and then the y value is the constant at the end. So the vertex is going to be 421. Okay, it's time for you to try one on your own. Rewrite the function f of x equals 2x squared minus 12x minus 20 in vertex form by completing the square. This one should look familiar to you. This is how I presented the lesson. So pause the video, take some time to review your notes and try this one on your own, and when you're ready to check your answer, you can press play. I hope you're ready to check your answer. So here we have a GCF. We needed to factor out that 2 from each of the terms so that we were left with an a value of 1. When we complete the square of x squared minus 6x minus 10, the constant that we needed to add and subtract was 9, because half of negative 6 is negative 3. When we square negative 3, we get 9. Then when we factor the perfect square trinomial, we get x minus 3 squared, and when we combine the negative 10 and the negative 9, we get negative 19. Then we redistribute the 2 to each of the terms, and it becomes 2 times x minus 3 squared minus 38. That's in vertex form, and the vertex is 3, negative 38. How did you do? Okay, if you have any questions, we'll talk about them in class tomorrow. Have a good night.